play around lots of times, and I get on YouTube and I find cute stuff. And all I did was go to YouTube and put genetics in. I looked at different ones, and my students have kind of censored some of them gone. So I'll show that one. Okay. Like first period is kind of the guinea pigs, and then what fifth period gets in the afternoon is like the cut the crap curriculum. They get exactly what worked with everybody else in the morning. So this is just a fun one to help you with like the P's. So let me know about sound, if you can hear it okay. Ready? Can you see it okay? Can everybody hear? Good?
Yeah. These days, scientists know how you inherit characteristics from your parents.
There you go.
They're able to calculate probability of
Pretty
having a
scary.
specific trait or getting a genetic disease according to the information they have from the parents and the family history. But how is this possible? To understand how traits pass from one living being to its descendants, we need to go back in time to the 19th century and a man named Gregor Mendel.
There's
Mendel was
Gregor.
an Austrian monk and biologist who loved to work with plants. By breeding from pea plants he was growing in the monastery's garden, he discovered the principles that rule heredity. In one of the most classic examples, Mendel combined a purebred yellow-seeded plant with a purebred green-seeded plant, and he got only yellow seeds.
Yeah.
He called the yellow color trait the dominant one, because it was expressed in all of their seeds.
They don't really
Then he
kiss,
two
but
yellow-seeded hybrid plants, self-fertilized. And in this second generation, he got both yellow and green seeds, which meant that the green trait had been hidden by the dominant yellow. He called this hidden trait the recessive trait. From those results, Mendel inferred that each trait depends on a pair of factors, one of them coming from the mother and the other from the father. Now we know that these factors are called alleles and represent the different variations of a gene. Depending on which type of allele Mendel found in each seed, we can have what we call a homozygous pea, where both alleles are identical, and what we call a heterozygous pea. This combination of alleles is known as genotype, and its result, being yellow or green, is called phenotype. To clearly visualize how alleles are distributed among its descendants, we can use a diagram called the Punnett square. You just place the different alleles on both axes, and then you figure out the possible combinations. Let's look at Mendel's P's, for example. Let's write the dominant yellow allele as an uppercase Y, and the recessive green allele as a lowercase y. The uppercase Y always overpowers its lowercase friend, so the only time you get green babies is if you have two lowercase y's. In Mendel's first generation, the yellow homozygous pea mom will give each pea kid a yellow dominant allele, and the green homozygous pea dad will give a green recessive allele, so all the pea kids will be yellow heterozygous. Then, in the second generation, where the two heterozygous kids marry, their babies could have any of the three possible genotypes, showing the two possible phenotypes in a 3-to-1 proportion. But even peas have a lot of characteristics. For example, besides being yellow or green, peas may be round or wrinkled. So we could have all these possible combinations: round yellow peas, round green peas, wrinkled yellow peas, and wrinkled green peas. To calculate the proportions for each genotype and phenotype, we can use a Punnett square too. Of course, this will make it a little more complex. And lots of things are more complicated than peas, like, say, people. These days, scientists know a lot more about genetics and heredity, and there are many other ways in which some characteristics are inherited, but it all started with Mendel and his peas.
all I did was go to YouTube and put in genetics, and I scrolled down and you'll see them. Wow. Yeah, it was easy. And of course you could save them and everything. But fun, huh? So, all right, cool beans.
Peas.
Cool beans. Oh, y'all are terrible. Okay. Let me get out of that. No, it's my golden right there. I lost 10 last year. Don't you wish they would live forever?
Yes.
And never and ever. Okay, so I'm going to show you some more stuff on this in a little bit later. But okay, so now y'all ready for dihybrids?
Bring it on, baby.
Y'all are lying horribly. All right. Would it make you feel better if I told you you weren't going to do it on a Punnett square? What'd you say?
Kind of like it.
No, Punnett square? Get out of town. All right, here we go. So do you want to do peas, or do you want to do the sweet little guinea pigs? Guinea pigs, okay. Because you never know what they're going to give you. I love it when they give you roan cows. Because we know so much about them, right?
Right.
Okay, but here's the deal. Regardless of what trait they give you, it makes no difference. The bottom line is it dominant or is it recessive? So it doesn't matter if you're working with mums or you're working with pigs or cattle or whatever. All right, you guys ready? We're going to cross two traits. Therefore, it'll be a dihybrid cross. Don't be afraid. All right? I do not like the Punnett square for a dihybrid cross. One, it takes too much time. Two, it is so easy to make a mistake finding your percentages. All right, so you ready? Okay, it's going to be a love moment for you. Here we go. We'll do guinea pigs. So we're going to do black fur. Now remember, this is the phenotype because, again, we don't care what the second one is, right? I have to give you a key, and so will your test. They have to give you some type of key. They have to tell you what is a dominant trait and what is a recessive trait. Okay, so we know this is white fur. Okay, and then we're going to go with a rough coat, which is, has that little wavy coat. It's called a rough coat. Is dominant. Is dominant over a real smooth coat. Okay, so there's your two traits. Carrie's way ready for this, man.
I know the answer.
Huh?
Just kidding.
You have an answer. What do you want? All right, so let's cross two hybrids together. And I'm going to go slow because I know some of you are just like really having to pull layers and layers of time off that file. Okay? Yeah. And don't hide. I want you to make sure you understand. All right. Step one. We're going to cross the same trait. All right, so here we go. Step one. We cross the same trait, which is going to be what? Everybody see that? Do you see? Step one, you always cross the color traits. It's going to be two hybrids. All right, now those of you that already know what it is, just wait for us, okay? All right, we're going to split this. Everybody see where I got that? Because what I don't want you to do is just copy it down and go on. I want you to see where I got it. So this is meiosis. One egg will get a dominant. One egg will get a recessive. Okay, down the side, one sperm is going to get a dominant. The other one's going to get what? Okay, so go ahead and cross that out. I don't think anybody's having trouble with that. Okay, is everybody good? All right. Okay, second step. All you need is the genotype. We don't need pheno right now. So what's it going to be? We need what? Pure, hybrid, recessive. Okay, so how many pure do we have? One. Right, 1/4. Good. How many hybrids? 2. Excellent, good. And recessive? 1. Very good. Now I'm going to give you all a hint. The nice thing about genetics is it's repetitive. So make a mental note. Anytime you see two hybrids crossed, it's always going to be 1, 2, 1. Always. Do you see it? I don't care if it's yellow peas, roan cattle, it doesn't matter. Two hybrids together is always going to give you 1, 2, 1. Just like you saw the peas, then the phenotype is going to be 3 to 1. Okay, is everybody okay with that? Okay, good. Step 3, set up the tree. Okay. Whoops, set up the tree. Yeah, we're gonna write it first. Because I want to do it in a way so that you can do this at home. All right? Okay, and remember, you can get online and you can actually order some practice exams. Practice them. Take them and practice them. Okay? All right, guys, ready? Okay, we're going to drop down here. Give yourselves room for step 4. But come down here. I'm going to go right halfway. Let me show you where I'm at. I'm going to come right over here on the halfway line. I'm going to set up my tree. Here we go. 1/4 is pure dominant. I'm on page 5. That's why I gave you a blank page. Okay. You're like, you did, right? I'm smart like that.
So you're like in this,
Uh-huh.
that we're right in?
Or wherever you can do it. Notice I put 3 branches coming off of that set. Does everybody see that? Good. All right, now I'm going to skip a little line. The key to this is not jam it all up. Then 2/4 hybrid, 1, 2, 3 branches off of it. This is my tree. I had the most fabulous genetics teacher in college. I'll never in my life be so grateful that he taught me how to do this for dihybrid, trihybrid, quadhybrid crosses. Okay? Dr. Pfaffenberger. He was as big as his name. Great teacher. 1/4. Okay, so when I set up the tree, I take the genotype from the first cross, which is just the color of the fur. I take each one of them and I put a 3 on. Okay, is everybody good? Okay, just to give you confidence, 7th graders can do this, so can you. All right? Okay, here we go. Don't grumble. Step 4. Now, I tell you that not to put pressure on you, but to give you confidence, okay? Step 4, cross the second tree, which is going to be the texture. Okay, so that's going to be this right here. So I'm going to circle that. See how I'm circling it? So my second tree is going to be 2 hybrids. Okay, now wait a minute. What do we already know?
We got
gonna
the
be the
same.
same.
It's going to be 1, 2, 1. All right, see what I'm saying? So you don't, I mean, it's repetitive. You don't need to work it out. So we know it's going to be what? 1, 2, 1. Okay, here we go. Step 5. Place the second traits genotype on the branches. Now this is going to get repetitive, but it's easy. Okay, so get that written and then watch. Okay. So 1/4 pure dominant, 2/4 hybrid, 1/4 recessive. You see what I did? Now what am I going to do here? The same thing, okay? So 1/4 pure dominant, 2/4 hybrid, 1/4 recessive. And the third set is going to be the same thing. Are you loving me yet?
Very much.
You just wait. Some of you are going to have an academic orgasm. I said that on camera too. Now put an equal sign out to them. It's all right. It's Laura. She loves me. Okay, is everybody with me? All right, here we go. So now, 6th step. Cross 1 branch at a time. Just 1. All right. you guys ready?
It says I said burn.
Yeah.
My brain.
My brain.
Seriously.
It's your brain.
No.
Hey, we got an easy escape, so unless we see flames, we're staying, okay? Or I'll teach out on the street. I did in South Carolina have a bomb scare right after Boston. And we had to move the workshop to a nearby hotel. We were going to move it to Starbucks or somewhere, but we were going to continue. They were looking at me like, yeah, I was like, you don't have the day off. Here we go. All right, now look how I'm covering this up, just to help you. Okay, you ready? Well, everybody look up first. You're going to cross this branch first. 1 times 1 is what? 1. Don't add it, just 4 times 4 is what? 16. Now cross your trait. Pure dominant, pure dominant. Okay, now what does that mean to you? This is what it means. That 1 out of those 16 squares is going to be pure dominant. Is that awesome?
I'm going to call my genetics teacher and give her a piece of my mind.
Uh-huh. You don't have to go look for it. It just tells you that 1 out of 16 boxes is pure dominant. I feel the orgasm. Yeah. Okay, so we're done with that one. So I just cross that out. And I go to the next one. 1 branch at a time. 1 times 2 is what? 2. 16ths. Now you always do this trait first. Pure dominant. And then hybrid. So 2 out of the 16 boxes is pure dominant with a hybrid. Okay? I'm done with that one. Y'all see what I do? Okay, you finish it. And then I'll go fill it in. Take 1 branch at a time.
Same math over there.
We'll see the pattern develop.
No, it's not over there.
How do you like that?
That's awesome.
Is that awesome? How quick is that?
A lot faster. We had to do the Punnett Square for all that.
Isn't that crazy?
That was just dumb.
How long did it take you?
Forever.
I mean, it takes you 10 minutes just to draw that thing, you know? Now, how y'all doing? All right, so genotype is 121, 242, 121. And as you notice, as you go down, notice it starts out with the strongest gene set and goes down to the weakest. It's already done for you. Easy. And that, as you guys were learning, that took 7 minutes. That's it. There it is.
Boom.
Mm-hmm. Easy, huh? Okay. Now, thank you, Dr. Pfaffenberger. Yes. Now let's do phenotype. Okay. Is everybody ready? Because I don't want to leave anybody behind. Do y'all see how easy that was? It was so easy. Don't mess up the next one. Okay? Because it's so easy. You'll go. And you'll skip a step. Just follow each step at a time. All right. Now let's do our phenotype. Does everybody see strongest to weakest? So if there's a question on there, and there is on your practice test about a dihybrid cross, you actually have to work it out. So you just work it out to the side, and you can figure out your percentage of which one you needed. Okay, so if it asks you, what would be the likelihood of getting, this right here, you know it's going to be 4 out of 16. Okay, all right, now let's do pheno. Watch this. You always start out strong and go to weak. Remember, we want what you look like. What does this guinea pig look like? Okay, so he's either going to have, and by the way, all you do is use your key. Okay? Is he got black, rough fur? Yep. Does he have black smooth fur? Okay. Does he have white and rough fur? Or does he have white and smooth fur? So see how you start out with the strongest to the weakest for your pheno. It is not surprising that your biology, this test you're taking, is going to be about 30 to 40% genetic questions, because biology in the last 10 years, especially the last 5, has really become genetically heavy. Okay?
How many questions are on the test?
I don't know. What is
80
80?
multiple choice.
80 multiple choice.
How
Multiple
many?
choice with the 80 multiple choice with the SAT, and you have about 4 hours.
Yeah.
4 hours.
And look how that just saved you. Okay, you guys ready? Okay, watch this. This is not hard. Once again, here we go. What color am I? I'm black and I'm rough. So there's 1. I'm black and rough. Okay, good. So there's 3. Now notice you're counting squares. So 1, 2, 3. Okay, I'm not black. I'm black and smooth here. Okay, what am I here? Black and I'm rough. Okay, so 3, 4, 5. Okay, what am I here? Okay, so there's 9, and then rest of it's okay. So how many black and rough do I get? 9 out of 16. That's right. Does everybody see where I got them?
Yes.
Okay, did you see where I got them?
Yeah, even if they were not dominant, you counted it though. 'Cause that's
Only,
a big B and a little b.
I'm looking for big B, big R.
Oh, just one of each.
One of
Okay.
each. See it?
Okay, I do
All
know.
right, good. So I'm done with those. All right, now I'm looking for black guinea pigs with smooth fur. All right, so I've already done those. So I come over here. What am I? Black and smooth. So there's 1. Notice how I do something different each time. So there's 1. All right, what am I here? Black and smooth. So there's 3 of them. And then the rest are what? White. Because remember now you're counting boxes. These represents boxes. Okay, so 3/16. Okay, now we just need white. I need white with rough fur. What do we have? 3 again. That's right. And that only leaves what? That's right. So my phenotype is 9331. That's awesome, wasn't it? Now, if we were doing punnets, we would not even be finished with our cross. And then you have to go back and figure all that out.